Hello students, this is my second lecture on BSc and BTech, and we will be discussing here a few topics of further topics of electromagnetic theory. And still now I am in the prerequisite of the electromagnetic theory. In last lecture I gave you some problem. If you remember, I gave you some problem, and this problem have been shown here. I'll discuss a few problems, and I hope by this time you have done a few. But normally your students never give feedback, so you also didn't turn back. One of them, I think so, has emailed me one or two problems, and rest none of the answers came here. So if I talk about the first problem, this type of problem are nothing but interpretation of vector notations. First thing you have to do is take x, y, z like this. In all the cases, maybe it is two-dimensional. The first question 1a is nothing but two-dimensional. You can see x and y is existing here. But the point is this: I have to analyze general, and that is always wise to analyze. See, from all this problem, these two perhaps you have done. Two of my students has indicated this. One of them answered this. This is I, y. So if this is my x-axis, this is my y-axis, and this is my z-axis, and I, y is somewhere here on this axis. If I change color, then it will be just on the y-axis itself. I, y is somewhat here, and I, j, x. See, remember, I, y is of the y-axis. Remember one thing: value of y is coming to x-axis, because I is of x-axis. Here we take I, here we take j, and here we take k. So what they are saying, this is I, y. This value y is nothing but its significant value. So the scale, what I mean to by saying this y, this is a scale and this is a scale. So whatever may be the value of the y scale, but I, y will lie on this value. Magnitude will be of this scale. Fine. Now I, j, x. J is of y value, so obviously x is the quantity. Our main concern is j, I, j, k, not x, y. X, y can be anything. So x value is taken here and plotted in the y axis for this problem. In this, we have I, y plus j, y. You see the condition. Reverse. I is with y, j is with x. So I want to plot this. What they're saying, you have to show with arrow, using arrow. Now here, this is with arrow, so here it would come out like this, and this one, second one, these two, D and E I am saying. Now I'll go to A. If I want to draw A will be somewhat like this: I, y, same value, plus j. See, now the question comes: the value of I is multiplied with some scalar quantity of y and some scalar quantity of x. So it will come out somewhat like this on this plane. XY plane is this. This is my XY plane. In this plane, we get somewhere in this. So this is one single vector, which is this. So maybe y value of I somewhat here, suppose say, and x value of j is somewhat here. So we extend these lines and we get this our vector. Remember, with arrow, this is 0 and this is obviously everywhere. X, y value will be 0, 0 in some case. What do you mean actually? We are showing different values. And say suppose this is my y magnitude of x in I axis, I hat, and this is y. So we compare this. This one, the magnitude of this vector, this part, I plus j, is square root of 1, because we take magnitude square root of 1 square plus 1 square, this is 1, divided. This is unit vector along direction of this. So this is the same vector, but here I change color and show you this is unit vector. So this is one unit vector. Maybe this is one, this much is one unit. So in the same direction I have one unit. This is a vector here. Then ij minus jy. Minus j is this side. Minus j is this side. So it will be ix, same value here, it is minus. So graph will be somewhat here on x minus y plane. This is minus y. So x minus y plane. So all are two-dimensional problem here. So complicacy is less. This is related to f is related to b, almost same type. Here they classically showing how magnitude is taken. So this itself is also unit vector, whatever value may be. Those who are just coming in from class 12, they might be having bit problem in this, but this is very usual problem that this itself is unit vector. It's visible because they have clearly mentioned x and y is equal to non-zero. So imagine if they would have given x and y equal to 0, you would have been in trouble, because anything divided by 0, 0 square would have been 0 and square root of 0 would have been 0, and anything divided by 0 is undefined. So this would turn to meaningless in that case. So by looking at this, you can easily say this is nothing but your value of unit vector. This one xy, to make you confused, this has been given xy. Now these are the similar types, you can handle them, only graphically you have to represent them. Again in second one they are asking, using arrows sketch the electric field of a unit positive charge situated at the origin. Note, you may simplify the problem by confining your sketch to one of the coordinate planes. Does it matter which plane you choose? So you can make it two-dimensional if you want, make it one-dimensional, two-dimensional only, and show it in one plane. But in reality, of course, it is in three dimension. So if I go for this, we have to again say very carefully that again the same diagram. You in all the cases, you in this type of problem you get same diagram. So I have three-dimensional structure. So this is my charge. Here I'll show charge with blue color so that you understand it in a better way. So this is my charge. I have my charge here, and the electric, they are saying electric field. Electric field will be, now I'm slowly entering electrostatics fully to understand electromagnetic in details. So what is our scheme actually in this syllabus? First we'll discuss about electrostatics, electrons and its field and its behavior. Then we'll go to magnetism and we'll talk about separately magnetism and its behavior, and then we'll combine them together and handle it together. We'll know electromagnetic theory as a whole. So fields are electric lines of forces are going away from positive charge like this in three dimension. One is coming towards you, one is going away from you. That is also fact, but I am giving you just one plane. So I have taken only xy plane. This is x-axis, this is y. I am taking only one axis, x-axis plane. So I can make the positive charges in this, and these are the coordinate plane, and I can say this is one field. It's being showing. I can show the field like this. This is the field in xy plane. So similarly, I can redraw it, try to understand, change color and show you. I can have another field like in this plane. What plane is this? If I draw like this, and like this, and like this, what plane is this? This plane. This plane. I'm talking about now this plane, and I have another plane like this. This plane is the orange one, and this plane is, what do you call it? Is this xy plane? This is x. This is only corresponding with x-axis, and the coordinate values here are showing x and z. So this is xz plane. This orange one is xz plane, and the blue one is xy plane. So we can take all combinations of x, y, xz, whatever you would like to. So then you can choose that. Third question, and they're saying write a formula for a vector function in two dimensions. See, here they're asking you to write a formula. Very tricky way and very nice way they have presented this. They're asking you to find out a formula, write a formula, because you should be very comfortable. Why they're giving all this? They want to make you comfortable with formulas so that you can speak in formulas. So first thing they are saying you, write a formula for a vector function with two dimensions which is in the positive radial direction and whose magnitude is 1. So first thing they have given the magnitude is equal to 1. So whatever may be the formula, if I have magnitude, so I can say x square, what they have given you, y square is equal to 1, that they have given you. That means x square plus y square is equal to 1 square, so that is 1. So this formula they have given you. If this is the case they have given you, with our basic knowledge of coordinate geometry, we can easily make out this is nothing but an equation of a circle. This is an equation of a circle. That is very clear to you, that if you plot the values of x and y in coordinate geometry, whatever value we get a circle. Now they are asking you, you have to write a vector formula for a vector function in 2 dimension, x and y, whose positive radial direction. So I want to plot a direction like this. So x and y square is equal to 1. So if I take xi plus yj, this is my unit, and divided by 1, that means square root of x square plus y square. This is my unit vector. Of which vector? This is my vector, and this whole sum is unit vector. So vector is just this, because unit vector is not a problem here. So you are left with only xi plus yj. This is your vector. Conventionally, it is wise to take x along with I and y with j, but there is no hard and fast rule, because here x and y is just numbers, scalar quantity. So you can multiply that as much as you want. There is no restriction to that. The second question, third, write a formula for a vector function in 2 dimensions whose direction makes an angle 45 degree with x-axis and whose magnitude at any point x and y is equal to x plus y whole square. Again, very interesting. See, intensity of the question is slowly increasing. You can see clearly the intensity of what you call so-called toughness is slow and steadily increasing, because your capacity is getting increased after knowing all these facts. So if I consider what they are asking you, that write the formula of a vector. So I have 2 dimension, so x and y let me take. They are saying it is making 45 degree angle. By saying 45 degree angle along with x-axis, if this is my x-axis, it is making 45 degree with x-axis. You are to write the formula makes angle with x-axis and whose magnitude at any point xy, suppose say this is my xy, this is my xy point, magnitude at any point is x plus y whole square. They are saying this magnitude. So I don't need to go for any square root anymore, because they mentioned it is to be magnitude. This is the magnitude. So unit vector in this direction will be unit vector in this direction will be x I, whatever may be xi, plus yj, we don't know anything, divided by the magnitude. So x plus y whole square, this is my magnitude, what they mentioned at this point. This is my unit vector. This value is my unit vector. Now I am not sure. In the previous numerical, we were sure this is equal to 1. Now I am not sure this is equal to 1. I am not clear, because I don't know value of this. So what I'll do, see, I'll redo everything here. I remove this. I hope by this time this diagram is clear to you. I don't want to change page, because this will make it more easy for understanding. So if I take the format of vector, we consider x hat, any vector, say a hat, is equal to a bar by magnitude of a. So a bar is equal to magnitude of a into a hat, and this whole thing is my unit vector. If you multiply this whole thing with this is my unit vector. Unit vector multiplied with magnitude of the vector will give you the vector. See, I am telling the thing beating around the bush. So if this whole thing which is unit vector, it is multiplied with the magnitude, that is xy whole square, then of course these will vanish and this remains. So equation is xi plus yj. This is how. Now in case you would have taken yi plus xj, how does it matter? It's all the same thing. It's not a different thing for you. This is how you are going to solve the problem one by one. I'll give you some more problem, but your interest is important for me. First you have to understand it and ask me for problem, then I'll of course, without solving problem, concepts will be never clear, because many points you must have seen while discussing theory cannot be discussed, but while discussing a numerical, many problems automatically comes up. Now we'll discuss about, just a minute, I'll get rid of this because you don't need me, because I need clear picture. Now we talk about surface integrals and divergence. When you talk about surface integral and divergence, we should be very sure that what we are talking about. When you talk about surface integral, that means we are very clearly talking about some integral, no doubt, but in previous lecture also I discussed that when you have two integrations like this and dx dy, we call it surface integral. You know it already. Now second part is divergence. What is divergence? Let me be very clear in a very simple way. You don't need to go for very mathematical implementations first. I have a charge here, just a charge kept. Charge in three-dimensional concept, charge is giving radiation of its electric field in all directions, on directions. Now if I consider this is my first sphere in which I have some area, and next moment I go to little further, we'll discuss more equipotential surface and all later, another area around which are concentric, again the same pulses goes, same electric field, lines of force goes in this, and we can say, if we observer standing somewhere here, we can say the lines of force are actually diverging. In simple words, they are getting diverted, they are diverging away from the point. They are not going nearby, they are going far off. The best example in our real life is light, which of course diverges. So divergence is a serious issue to understand higher level physics, because in many cases we have divergence, and if we know mathematically how to handle divergence, the story becomes quite easy for us. So we mathematically analyze divergence, and after knowing mathematically divergence, we handle that and apply that in all other factors. So basic fundamentals, concepts of divergence should be very clear to you. To talk about application, and already the knowledge you have still now is Gauss's law. Here we know the dot product of this electric field and the surface area vector is integration of area vector is equal to q by epsilon naught. This is of course a scalar quantity, and this is of course equal to phi. Phi is flux. That means that E dot, you just see, if I consider this E dot n hat ds and integration, surface integral, if this is vector, if I elaborate this, I can also write this as es E n hat, magnitude of n hat, magnitude of E cos theta ds. So this turns to only E n hat magnitude is unit vector, so this is 1. So we are left with surface integral of E cos theta ds. Now see, this is a bit complicated. It looks very simple. This cos theta is actually, is it a variable with respect to the area ds? If this cos theta is a variable with ds, then I cannot bring out easily. I have to differentiate it, integrate it. But is it wise to claim cos theta to be variable in this case? We cannot make general formula. We simply cannot make general formula, but we have to specifically consider whether in some cases these are same. What do I mean actually in this? We have a charge and we have some surface area around it, and this ds, integration of ds is this surface area. If it is spherical, then it's 2 pi r. If it is not spherical, suppose like this, the charge around the charge, then also we can consider that to be a spherical area. Try to understand this. My main target here to make you understand this, because when we take unit normal vector, at this point unit normal vector is this. Let me change color to make you understand better. So in spherical, this is my area. So area vector and the electric lines of force are having 0 degree in this case, because area vector is in this direction and always perpendicular to the area, and electric field also in this direction, so there's 0 degree, and cos 0 is 0, so it vanishes. Now let's take about some other case where things are not so easy. Let's take about a case, let me find some area. Yes, suppose say this area. Here the electric line suppose are going like this, and this area I'm talking about. Say suppose this bit flat like this, and this is the area. So in this case, the area vector E is this. Area vector is in this direction, and E is in this direction. Angle between them is 90 degree. This is sharply 90 degree. Cos 90 is 0. The flux becomes 0. That means we won't consider this rough area. So in a whole sum, if I have a rough shape like this, it doesn't matter, because area will be considered as 4 pi r square area of a spherical structure, even for a odd surface, because electric lines of force will cancel with the area if they are not having same direction. They will reduce or they will decrease somehow. So ultimately we consider this to be 4 pi. That means theta is not a serious concern. It's not a variable changing element in the case, in this case, this particular case. Some of you may ask me, sir, S is equal to r theta. So I can also write ds is equal to r d theta. Who says this? I can also write ds is equal to product form r d theta plus theta dr. That is also possible. That is also possible. So in integration, one should be very clear that what is your variable, that depends on the situation where you are applying it. There is no hard and fast rule for considering variable in an integration or constant in the integration. One same thing can be constant in some case because you are applying them. In maths, they have defined rule. They consider something to be constant, they will say you this is constant. But in physics, we don't define any constant. We have more uncertainty about constant and what is variable. So you have to be very conscious in handling them. Depending on the situation, various questions are being asked to make you confused about what is variable and what is constant. So take care of that very seriously. Now I'll come to the core topic. You can see some 3 figures here. 3 figures are nothing but they are showing you 3 structures of the same field in a magnified view. In simple words, this is showing a plane where this is my unit normal vector or area vector, and this is my z direction, and the field is in xy plane, so it is 3-dimensional. And in sphere, the one almost in figure 2, almost the same thing I talked about. In case they are a bit different, there's some angle between n and the electric field, then we have different story dictated by this formula. But whatever may be, the right hand side is only q by epsilon naught, and epsilon naught you cannot change at one go, and q, you have taken some q at the center, so there is no question of changing it. So now we will concentrate more into unit normal vector how actually to handle this. In case of, you must have seen while explaining you this, I talked about some rough area, because see, one case I said this is 0, and extreme two cases I explained this is 0 case and this is 90-degree case. Fine, no problem in that. What about the in between cases? You have also in between cases, like something is 30 degree, between 0 to 90 degree also we have some values, and how to handle them. This is one case. Suppose say we have, this is one case I am saying, with one charge you have one vector, electric field is vector. But suppose say there can be some cases like there's some dielectric medium changing in between, and some two lines of force are going nearby like this, or getting divergent in between due to some reason. So how to handle them? So we are going to handle now N. If we see this plane, it's a rough plane, any shape plane, surface area, and we concentrate to one point P. Say suppose at P we have two vectors u and v passing by. They meet. Of course, we cannot say they originate at P, but we say they are tangent to P. At this point, this may be u coming in this direction and v was coming in this direction, and they coincide at this point P. If so, then we can take N, because you see this uv is in one plane. This S plane is irregular shape, no doubt in it. But uv, they are touching a point, single point on this surface S at P, but they are actually on one plane, one single plane. If these two vectors are in one plane, and as per rule this area vector or normal vector, unit normal vector, is perpendicular to both u and v, if this is satisfied, if with v also it is 90 degree, with u also it is 90 degree, if this condition is satisfied, then u v are also in same plane, then we can say that N, this is my N, this is my N, N is equal to u cross v, because cross product, result of the cross product leads to your third vector, and that is N. And unit vector N hat, what we have already discussed, is equal to N vector N by N. And N we found vector N, this is vector N is equal to u cross v, and unit head, unit N is of course u cross v, magnitude of u cross v, because if you take magnitude, this becomes magnitude. This is how we can find out the unit vector of a plane at that plane. Suppose they would have given some other N to ask you to find some other N here, then you would have considered some other two vectors or three vectors or whatever may be. So then if they satisfy that condition, this is also 90 and this also becomes 90, under that condition you can apply that to be N. Otherwise that is not the area vector. So everywhere, see this N, I call it N dash, are different, they are not same, and they have some relation, because this, see the fun, you have many UVs on the plane, and you ultimately find out different N's, and N dash, N double dash, and so on and so forth, and you can correlate, then you concentrate to only the relation of N and N dash and N double dash and all this stuff, and then you can actually conclude. And that is the benefit of taking unit vector or normal vector to analyze in a complicated case. Now I'll go to my next point, which is more elaboration of this, because you have to be very clear about what we're discussing. See, for example, this is a function x, z is equal to, what is a function? Z is equal to fxy. So you have an expression here, the one I explained you right now, uv. There's a bit haziness, but this will make it more clear picture. I separately take u and I separately take v, and we are slowly moving to differential form. This is the first time you can see evolving of differential form. Please try to understand, hold your breath and try to understand this, because from now onwards you will slowly come with differential form, because differential form is the best way to explain this. How you will understand right now. Suppose this is my xyz plane, three-dimensional concept, and I have a surface S like this, arbitrary surface, and this is my point where u is one of the vector in this direction. If so, I can easily elaborate this further, that this is in the, I can consider that to be xz plane, because this is parallel to xz plane. This I consider to xz. This is y, and this is z, and this is x. So I can take this one parallel to in the xz plane, in the xz plane simply, nowhere else, in xz plane. And if I consider that to be in xz plane, then you can see here, if in case it continuously doesn't matches with my x-axis, there is a difference. This is a function. Remember what I said in the beginning, z is equal to fxy. We have z is a function of x and y. So we have z as a function, this whole plane, this is nothing but z is a function of x and y. So every point x and y will change, and that will lead to change in the z direction. There's lots of difference, you have to understand very carefully. We talk about x and y, change of x and y in every point, means this value and this value changes, and leading to z changes. What we're talking actually about, if at every point x and y changes and leading to change in z, we are definitely talking about normal vector, because z is always perpendicular to x and y. At one go we cannot take up the whole plane, but separately we can separate out p, all this stuff, and we can easily solve out. Now see what they are doing here. In this, they have taken z and x plane, this plane where I have already drawn, and suppose say this is bit diverted. You can see this is my u, they are showing u, and this is bit diverted. The u can be resolved into two components, x, y and x, z. And in this plane, x and z plane, I can resolve this into u, x and u, z. Got my point? U, x and u, z, because I can resolve it into two components, the u, always. So u, x is this, we have no problem with this. And if this angle between u, x and u is 0, then ux itself is u, I have no problem. Then u will be having 90 degree with uz. I can say in that way also. Try to understand this. This is nothing, this part is nothing but along with z, uz. So uz is nothing but, I can say, see, it is changing with respect to x. My variable in the function is x and y, not z. Z changes because of x and y. So whatever u is showing, whatever change u is showing is differentiable, is z. F means z, indirectly we mean to say a function is differentiable with respect to x, because we have no option of y in this. We have not considered here. We can separately consider yz even. Is it clear? This is bit complicated concept, but this is how we. What does this means? When we write ddx del actually del x of f, that means f is a variable with respect to x, and that is of course known fact, because f is function of x and y, so it will be a variable, and that is of course z. So z component, that is yz, we consider as del x of f. Now come to equation. If I want to write equation of u, just before that you have done some numericals, and in that we talk about making of equation. Similarly with ijk, we consider there is no option of j, because we don't talk about y-axis in this. So we take u in vector form is equal to I, because ux is along the x-axis, so I say I ux plus k. K is prefix of z-axis, we know this already, and this value ddx of f ux. Ux is the resolve. See what we are doing. This ddx of f ux is nothing but a fraction of this part, which is perpendicular to ux. If ddx of f becomes 1, then what does it mean? If ddx of, what do you mean by differentiation of something is equal to 1? Then fx is x, f is x directly. You can say fxy is equal to x directly. It has got no other variable. That means this part is making everything clear. With this we are sure that we are talking about, and this is multiplied with ux. Why ux? This may be a question in your mind, that why ux? It should have been something else. We are taking component of this, and this differentiation multiplied with ux will give you this length. Why? Because I have taken the z component in this, and this value multiplied with this will give you the together value of this. Reason is very simple. I cannot claim y z component. Indirectly I can say this is y u z. This is nothing but equal to u z together. U z is dependent on, see, here's something, I'll give some physical example. Suppose say your water overhead tank, there can be overflow in it if more water pours in, but if in your city the water supply is less, then you can never think about overflow, but you make provision of overflow in your tank. Though you know there is always water shortage, your tank is never going to overflow, but even then you make a provision for overflow. This is supposed to be my overflow. When you know this is, because why you make provision for overflow? Sometime you are out of station and your tank is, water is not used, there can be overflow. Now another function of function. You talk about a senior citizen who will never leave house, will be never out of station. Suppose he doesn't or she doesn't want to go out of station. In that case, chance probability of overflow will reduce. So what we are saying, we are considering in terms of overflow. Our function is actually water supply, and we are talking about overflow. That means overflow is actually a function of water supply indirectly. It's not directly, indirectly. Is it clear? I think so. That will make it more clear. So we consider this and multiply both, we get z function, and we take ux common, and this becomes our equation. So u can be simply written as I plus k ddx of del del x of f ux. This is whole sum vector, and see carefully, ux is a scalar quantity. We don't give any, we just give value to this, because if you don't give value, you cannot find actual diversion, how much it is happening, and slowly we are moving towards divergence, but not right now. Let me analyze another vector at the same point, some other point v of the same plane. In a different mode we have taken that plane. Now here the same story. I think so I don't need to explain it again in details. You can understand it much better way, that we talk about this and we take jv, and this is my case and this is my case, same story, there is no other repetition, and we take vy common and we get the equation for v. Now from this we are going to find out n. That is very interesting. We are going to find out n. See this, very simple. You will understand it very easily without any hassle, and very clearly, because basics should be clear, then automatically things becomes very comfortable to you. We can take uv will turn to this. I think so I don't need to explain anything in this. We have taken cross product of u and v, and after finding out u and v, you can easily find out this value. You can multiply and find out. Now we want to know n hat with respect to x, y, z. See the purpose. N hat, if you do this, n hat x, y, z, then any arbitrary surface, they may give a surface like this, you can find out n hat x, y. This is n hat. I cannot call it n hat directly, n x, y, z, and this is also n hat, or this is maybe this is other way around, this way, n hat. If I say x, y, z, I can pick generally one x, y, z. So I have no problem in understanding this. So in all cases I can find out u and v. And advantage you are getting of this is going to give you advantage, because here you have differentiated del x of f. More general term, f is what? Actually you are writing del x of fxy. So you are differentiating x and y always. In case x is dependent on y and y is dependent on x, you actually go for the product form of differentiation. You differentiate both, or if one of them is constant for other, then also you have your option. So you are making more general structure by taking this equation. And ultimately you find the unit vector. You take the vector equation, divide that with the magnitude of that vectors. We all know that vector divided by unit vector, magnitude of the vector, is the unit vector. So we have taken unit vector. This is looking very simple, but this is one of the gigantic equation going to give you many concepts very clearly. So in xy plane, if you take example, they are giving you xy plane, you have z is equal to fxy is equal to 0. That means, no, if it is 0, function is, this will turn to 0, this will turn to 0. Equation becomes very simple. This is 0, this is 0, only k is left. It's quite common sense that xy will lead to a vector in the cross product, a vector which will be perpendicular to both. And when these are 0, now the concept I told you, remember, you have a charge, you have a spherical structure, and you take non-spherical structure around it. What I actually said will be now very much visible to you, that this is my n, this is my e, and at this point this is n. I'll change color and show you, it will make it more clear. This is my n in this direction this is n, and in this direction this is n, and this is n. Various n we have, but all n are nothing but function of x, y, z. I am taking general. I won't take the headache of considering different n at different point, because they can be anything. Think about a radiation from an antenna. I am talking only the electrostatic part of it, though antenna gives you electromagnetic. But I cannot take headache of running after each and every point. So I take a general format like this, n hat xyz. It can be anything. This is also n xyz. This, which is just odd for this is also xyz. I can take general structure, because uv I have taken general, and more importantly, within uv I have uv itself is having a more general structure of del x of f and del y of f. So in case they are having no relation x and y, this turns to 0. So in generally, if this del x of f and del y of f turns to 0, you are mathematically very clear that this becomes 0, this becomes 0, this is 1, square root of 1, and only k remains. So you are remaining with k, which is nothing but indicating the normal is along the z direction. So think about this sphere in a three-dimensional figure structure coordinate system. Reference point I am taking three-dimensional coordinate system. Every n x, y, z, some of them, what I said then, some will be equal to I said in terms of cos theta dot product, in a very raw way, in a primitive way, that if it is 90 degree, it is going to be 0. One case, there was a hazy thing, I talked about one case 90 degree, I talked about another case 0 degree, when you have maximum e and n hat unit vector is getting uniform and supportive, and in 90 degree case it is getting vanished. I could not say anything, because between 0 to 90 I can reduce the values up to minute levels, theta values, and I can calculate infinite number of readings in them. So that will be great problem for me, but this type of approach will help you to understand it much clearly. So we are concluding this equation, which is going to help you to understand it much clearly. I hope things are clear. In next lecture we'll be slowly becoming more intensive, because initially I want to be a bit comfortable, and slowly and steadily will be more intensive. Thank you so much.